Stretching across northern France, one of the largest construction sites in Europe is taking shape day and night. It is the Canal Seine-Nord-Europe, a multi-billion-euro megaproject that France has pursued for more than 200 years. With more than 57 million cubic meters of earthworks, 107 kilometers of canal, and massive locks capable of lifting 4,400-ton vessels like giant water elevators, this is an investment of more than 7 billion euros aimed at ending decades of French decline in Europe's inland waterway logistics race. Yet this very canal is also fueling intense controversy. Rather than being widely welcomed, it is viewed by many as a multi-billion euro environmental disaster and a completely unrealistic megaproject. So why is France willing to stake the future of its logistics network on such a controversial undertaking? Join Mandarin Tech as we explore the answer in today's video. To understand why this canal is worth billions of euros, we need to look at the logistics landscape of Europe. In Germany and the Netherlands, major ports such as Rotterdam and Antwerp rely on vast inland waterway networks to carry more than 50% of domestic freight traffic. Meanwhile, France had pursued the dream of connecting the Seine Basin to northern Europe since the time of Napoleon, yet failed to achieve it for more than 2 centuries. As a result, despite possessing Le Havre, its gateway to the Atlantic Ocean, the flow of goods remained constrained by the Canal du Nord, a waterway built in 1908 with a carrying capacity of only around 650 tons. This bottleneck effectively isolated the Seine River network from the massive freight corridors of northern Europe. The consequence was that inland waterway transport accounted for only around 3% of freight movement in France, forcing the vast majority of cargo onto increasingly congested highways. That is why the Canal Seine-Nord-Europe had to be built. It is the crucial missing link that will permanently connect the Paris Basin to Europe's vast inland waterway network, a remarkable transformation that could reshape the continent's economic landscape. Before becoming a massive logistics corridor for Europe, the Canal Seine-Nord-Europe had to undergo the largest landscape transformation project in France in decades. More than 57 million cubic meters of earth were excavated to create a gigantic 107-kilometer waterway corridor, making it one of the largest earth-moving operations in modern Europe. If dump trucks were used to transport all of this material and lined up end-to-end, the convoy would stretch all the way around the earth. The process began with the construction of dozens of kilometers of service roads, allowing dump trucks, excavators, and heavy equipment to access the construction sites. Then, a fleet of giant excavators started cutting deep into the ground to shape the canal alignment with precisely controlled width, depth, and slope, ensuring that vessels nearly 200 meters long could navigate safely. But that was not all. To make room for the new canal, part of the Oise River also had to be diverted. Engineers excavated an entirely new river channel, stretching several kilometers, then gradually redirected the water into its new course. However, rather than turning it into a straight concrete canal, they deliberately created natural meanders to restore ecosystems and reduce environmental impacts. Once the massive canal trench had been excavated, another major challenge emerged. How do you prevent 21 million cubic meters of water from gradually seeping into the ground? With a width exceeding 50 meters and an enormous volume of water, the pressure exerted by Canal Seine-Nord-Europe on its banks is immense. If the underlying soil were to become unstable or water began to infiltrate the ground, the entire canal bank could collapse or deform under its own weight. As a result, after excavation was completed, engineers reinforced both sides of the canal with multiple layers of materials designed to stabilize the ground and provide long-term protection against erosion. In addition, to prevent water from leaking into the soil, engineers made use of the excavated material itself, mixing it with the region's naturally occurring white limestone to create a mineral-based waterproofing layer. In other words, the canal is almost sealing itself using the very material removed during its construction. After the soil and limestone mixture is spread evenly, specialized machines repeatedly crush, mix, and compact it to create a dense, stable foundation layer that helps retain water within the canal and ensures the long-term stability of the entire structure. However, Excavating a canal stretching 107 kilometers was only half the challenge. Northern France is far from flat. From one end to the other, the Canal Seine Nord Europe route must overcome an elevation difference of nearly 54 meters. And of course, vessels weighing up to 4,400 tons cannot simply climb uphill between different water levels. That is why the project requires the construction of 6 giant locks distributed along the entire canal. Each lock is a concrete chamber measuring 195 meters long and 12.5 meters wide, operating like a giant water elevator for ships. When a vessel enters the lock chamber, the steel gate behind it closes. Tens of thousands of cubic meters of water are then pumped in or released to gradually raise or lower the entire vessel to a new elevation before the gate at the opposite end opens. The smallest lock only needs to lift vessels by about 6 meters. But in Pas-de-Calais, the Marquion-Berlin lock must overcome a height difference of more than 25 meters. That is equivalent to lifting an entire vessel nearly 200 meters long, together with thousands of tons of cargo, to the height of an 8-story building. Despite its enormous scale, the entire lifting or lowering process takes only 10 to 13 minutes, thanks to a system of control valves and hydraulics engineered with precision down to the millimeter. But the greatest challenge remains the amount of water lost during each operation. To address this, the Canal Seine Nord Europe incorporates giant water-saving basins capable of reusing more than 75% of the water after each vessel passes through. The remaining water is pumped back to the upper level by massive pumping systems to maintain a stable water level throughout the canal. And to prepare for prolonged summer droughts when evaporation reaches its peak, a strategic reservoir with a capacity of 14 million cubic meters has been constructed at the highest point of the canal route, a vast reserve designed to ensure that the water depth along the entire canal never falls below 4.5 meters. Once the lock system was in place, engineers faced a unique challenge. How could they carry the canal across the Somme Valley without destroying the wetland ecosystem below? The solution was to lift the entire canal into the air using the Pont Canal de la Somme, one of the most impressive structures of the entire project. Stretching more than 1.3 kilometers in length and rising nearly 30 meters above the valley, the bridge carries a massive body of water and vessels weighing thousands of tons across the landscape. To build the structure, engineers first drilled deep foundations and erected gigantic reinforced concrete piers. They then installed a prestressed concrete water trough above them, designed to withstand the weight of tens of thousands of tons of water and passing vessels while ensuring complete water tightness to prevent leakage. Once the main structure was completed, waterproofing systems, drainage networks, expansion joints, and structural monitoring sensors were installed to control deformation and ensure the long-term safety of the bridge. By suspending the canal above the valley, the Somme River and the ecosystem beneath it remain almost entirely untouched. It is a powerful demonstration that large-scale infrastructure can adapt to nature rather than erase it. However, excavating the canal itself was only half the challenge. To prevent the Canal Seine Nord Europe from severing the existing transportation network, engineers had to construct 62 road and railway bridges, as well as 4 underpasses crossing above or beneath the canal. Each structure presented its own challenges in terms of structural engineering, hydraulics, and traffic management, while also having to be built in carefully planned phases to maintain connections between towns, villages, and industrial zones along the route. One of the biggest bottlenecks was located in Noyon, where the new canal crossed Departmental Road 934 and the Western Bypass. To maintain traffic flow, engineers first constructed a temporary diversion route, then built a new bridge, and finally closed the old road to make way for the lock and the canal channel. For the railway network, the challenge was even greater. Approximately 3 kilometers of the Amiens-Laon railway line had to be rebuilt, together with a new overpass, to make way for the canal. The project was carried out by Eiffage and had to be closely coordinated with the canal excavation schedule to avoid disrupting regional rail traffic. Behind the entire project stands a 3-dimensional BIM system and a digital twin, containing more than 1.2 terabytes of geospatial data and allowing 370 engineers to work simultaneously on a single platform. This enabled design conflicts to be identified and resolved before construction began, helping to avoid costly mistakes that could have delayed the project and added tens of millions of dollars in additional costs. When the canal enters operation in 2032, this model will become a permanent digital twin of the entire waterway, storing the operational and maintenance history of every component and helping operators shift from reactive repairs to predictive maintenance before failures occur. After more than a decade of construction, the Canal Seine Europe is expected to become a key link in the inland waterway corridor connecting the Seine River Basin with the river networks of Northern Europe. The new canal will allow large barge convoys to travel directly between Paris, France's seaports, and the Benelux region, significantly reducing pressure on an increasingly congested road network. According to planners, the project will help eliminate millions of truck journeys each year, reduce greenhouse gas emissions, and enhance the competitiveness of industrial zones and logistics hubs along the route. For France, this is not only a major transportation project, but also a strategic investment aimed at strengthening the country's position within the European freight transport network of the 21st century. However, during implementation, construction costs continued to rise due to inflation and increasing prices for materials, energy, and labor. The total investment has exceeded the original estimates by a considerable margin, sparking debate over the project's economic efficiency and financial burden. Nevertheless, supporters argue that the long-term benefits in trade, environmental sustainability, and regional connectivity will far outweigh the additional costs incurred today. If successful, the Canal Seine Europe will help reshape the flow of goods between France and the rest of Europe for decades to come. In that case, it will be more than just a new canal. It will stand as a symbol of the ambition to build a greener, more efficient, and more sustainable logistics system for the future. But to truly understand the scale of Canal Seine Europe, we need to look at a project that transformed global trade more than a century ago, the Panama Canal. For hundreds of years, traveling around South America to connect the Atlantic and the Pacific meant a perilous journey. More than 20,000 kilometers, equivalent to 12,400 miles, of additional sea travel, weeks spent at sea, and constant exposure to violent storms. The dream of creating a shortcut between two oceans emerged in the 16th century, when Spanish explorers realized that the Isthmus of Panama was less than 80 kilometers wide, equivalent to 50 miles. But it took nearly 400 years, and the involvement of two major powers, France and the United States, for the world to finally witness that vision become reality. After more than a decade of cutting through mountains and jungle, moving hundreds of millions of cubic meters of earth and rock, building gigantic lock systems, and paying the price with the lives of tens of thousands of workers, the Panama Canal officially opened. This became one of the most expensive and ambitious engineering projects in the Americas, with a total cost equivalent to more than $10 billion today. And from that moment on, this waterway permanently reshaped global trade. The idea of linking the Atlantic and the Pacific by water has haunted humanity for more than 500 years. But it was only when the Panama Canal was completed that this dream became reality. Connecting the two oceans created a huge leap in transport efficiency. Instead of sailing more than 20,000 kilometers around South America for nearly 2 weeks, ships now need only about 8 hours to cross Panama, nearly 40 times faster. This reduction in travel time not only saves fuel and operating costs, but also accelerates global cargo flow, helping businesses cut inventory and optimize supply chains. With this strategic role, the Panama Canal has become a crucial financial pillar for the country, generating more than $2 billion USD annually from transit fees, accounting for about 3% of Panama's GDP. Large vessels can even pay more than 500,000 USD just to pass through, a fee regarded as the most expensive in the world for a distance of only 80 kilometers. Although it is more than 110 years old, the Panama Canal remains an irreplaceable link in the international trade system. To visualize this clearly, imagine a massive container ship traveling from the Atlantic to the Pacific. Without the canal, the entire American continent would become a wall blocking its path. The only option then would be to sail around the treacherous Cape Horn, adding up to 15 extra days at sea and consuming thousands of tons of fuel. Thanks to the canal, 6% of global trade, including energy, consumer goods, agricultural products, and industrial components, is transported faster and more cheaply, helping maintain the continuous flow of goods between Asia, North America, and Europe. For that reason, any disruption in Panama can create a domino effect on transportation costs, logistics, and global supply chains. More than a century has passed since the SS Ancon glided through the first steel gates of the Panama Canal, opening a new chapter for global trade. From a 500-year dream to a project built with blood, sweat, and human lives, the Panama Canal is not just a route connecting two oceans. It is a testament to human will, boldness, and ingenuity in the face of harsh nature. Today, every ship that passes through these waters is a reminder of the tens of thousands of workers who fell, and of engineers like Stevens and Goethals, who once stood before challenges no one else dared to face. The colossal locks, the vast Lake Gatun, and the 80-kilometer waterway across a continent do not merely transport goods. They carry the spirit of human progress. And as ships continue to cross the canal under the sunrise of the Atlantic or the sunset of the Pacific, we understand that this wonder is still writing its story, a story of determination, innovation, and the belief that for humanity, nothing is truly impossible.